Hello, everyone, and welcome to the easings Symphony. If this works, AnimationSpec in detail. For those who don't know me, my name is Nicole Terc. I'm an Android GDE and also a tech lead at HubSpot, and you can find this and more ramblings in my GitHub profile following that QR code. Cool. With this out of the way, let's take a look at what are we actually going to be doing today. We're going to be touching into three main things. We're going to be talking about animations, we're going to be talking about AnimationSpec, and we're also going to be talking about easing. And in order to tie these all three together, we're going to be making some funky music visualizers. Cool. So let's get started, and let's start talking actually about music, because you cannot see anything if you don't have the source, right? So when talking about music, the part I want to focus about is like, how do you actually animate music, right? So searching online, I found out that most music visualizers focus on three main things, which are waveform, amplitude, and frequency. And well, there's a lot of logic about and information about what these are and how they're calculated and all that. I'm not going to get too into it, even if I would love to. The only thing you need to remember is that waveform is kind of like the blueprint of the whole audio. Amplitude is going to be kind of like the loudness of the sound. And frequency, which, by the way, we have low frequencies and high frequencies, are going to determine the pitch, which is tied to like the notes that the sound is playing. Now, I haven't actually answered the question of like, how do we actually animate this thing, right? So the strategy is pretty straightforward. You're just going to grab your nice little music, you're going to split it in several frames, and between each of the frames, you are going to check how these values are going to change. Like, for example, how the amplitude is changing between them, or how the different frequencies are going to be changing among them. Cool. Now that we know how to animate music, the next step is actually to create a music reader, right? We need to read this music. Now, since I'm going to be creating this music reader for Android, iOS, and desktop, the easiest way to create this music reader is, of course, to start with an interface. So my interface is pretty simple. It's just going to expose some flows for each of these properties, and it's also going to have some helper functions that are going to help us to like load the file, play the music, and stop the music. Cool. Now that we have our interface, the next step is to basically create an expect function provider for this music reader. And for each of the platforms that I'm going to be supporting, I need to create the actual implementation, right? So again, I won't go too deep onto music reading. I already skipped all the slides on that. So the only thing you need to be aware of is what am I using for each of them, right? So for Android Music Reader, I'm going to be using Media Player and Media Extractor to get all this information. For the iOS one, AV Audio Player. And for desktop, I'm going to be using Clip. If you're interested in the actual implementation, you can take a look at the code that is going to be linked at the end. Don't worry. Cool. But with our music reader ready, we need to start doing something with it, right? So let's create a simple visualizer. And in order to do that, it's pretty simple. You're just going to create your new composable. You're going to start listening to these different properties that you have, and you need to draw something, right? Whenever I'm starting to like figure out how this information works for me, the first thing I usually do is just create a canvas. And that's actually pretty easy, because Canvas is going to be refreshing the things, so I don't need to think too much about like, is my state updating or not? Canvas is going to draw whatever I'm sending to it. So once I create different canvas for each of them, I can have a simple music reader visualizer, right? And if you run this, nothing happens. And that is because we actually haven't added any music yet. So another important step about creating music visualizers, of course, is to get some music. So you can use your favorite source for this. In my case, I just went around and poked my like super cool brother. So after getting some information with him and getting like some different sessions for getting some music, he basically gave me a WAV file that I was able to just add into my file resources. I highly recommend you work with .wav files because it's easier to work with. And once we have this, we basically go to our previous composable, we load the file using resget URI, and there you go. Some music. which you can hear, right? It works. Now, well, this music is already kind of like being animated because of Canvas. I think we can do something more interesting with this, right? So let's jump into our visualizers. And in order to make these visualizers, it's actually going to be animations with a hat. So let's jump into our animations. And let's create a super basic animation to start these visualizers. In this case, it could look like this. You just create your basic like amplitude animation. In this case, I'm using amplitude because it's the easier one. You just basically collect it as a state. Once you have it, you pass it into your lines little box, which I'm going to call bold, so it's easier. And once you have this information, you just pass it into your graphic layer as a translation Y, and that's it. So this is a simple screen yet, but we haven't added the animations, right? So in order to do that, the only thing you need to do is instead of passing the value straight away, we're going to grab that value inside an API, which in my case is I don't want it to do anything too complex. I am just going to use the animate float as a state. That is going to convert whatever this value I have, and instead of just changing it right away, is going to do it sequentially, right? Cool. Now, by running this code, you already have a super simple music visualizer. Nice. I'm going to just raise the volume. There you go. But I think we can still do better, right? So let's create something more interesting, and let's start customizing this thing. And the first step, whenever you want to customize something, you should think about is AnimationSpec, which is going to be our first customization of the day. Now, this AnimationSpec property you're going to find in most of the animation APIs, and it's basically going to be an optional property inside them, right? Simple. But what is actually AnimationSpec? If you take a look at the documentation, you end up with a definition like this. It stores the specification of an animation, including the data type to be animated, and the animation configuration. Cool. It may be clear for you what this means, but for me it wasn't. So whenever I find myself in this position, I do as I always do, and I basically just command click into it, right? So in the case of AnimationSpec, we find this interface, AnimationSpec, that basically just has a function called vectorize that returns a vectorized AnimationSpec. Cool. I still don't know what this is, right? So let's command click again. This looks promising. So the interface of vectorized AnimationSpec, it's actually an interface that is going to contain the logic that we wanted. So this one has 4 components. The first one is a Boolean that is going to tell if your animation is going to be infinite or not. And the other 3 are basically get value from nanos, that is going to give you the actual value of the animation at a given time. The velocity from nanos, which is going to give you the velocity at a given time. And the duration in nanos, which is basically the duration of the whole animation. Nice. That gives me a bit more information on what is happening, right? So with this information, we can go back to our previous definition of it, and we can update it that, yes, it stores the specification of an animation, including the data type to be animated, but it also stores the value, speed, and duration at a given time in its life cycle, right? But don't worry, this will just be indulging myself. You actually don't need to know any of this, because a lot of animation specs actually come out of the box. So you don't need to create anything or really understand them too much in order to use them. The 3 main animation specs that are available for us are these ones. We have Spring, which is a physics-based animation spec that is going to simulate a spring. We have Tween, which is a time-based animation that is basically just going to linearly animate from one point to the other. And we have one of my favorites, which is keyframes, that is basically Tween, but more powerful, because it's going to let you specify specific keyframes you want your animation to reach before finalizing, right? Like in the case here, I'm setting that the first keyframe should always be the bottom one. Cool. Now, in order to use these things, as I mentioned, it's just basically changing the animation spec property that we have. And they look like this. In order to make it be a spring, we just need to create our spring animation spec pass a damping ratio and stiffness, which are the properties that are going to help us calculate this value again among the time. In order to use tween, we actually pass duration directly and pass some easing, which I'll touch later. And in order to create keyframes, we again pass duration, and we then start specifying which keyframe we want. As you saw, each of them is like, what, 2 lines, 1 line if I am lazy. And with this, we already have different animations, which look totally different among them by just changing a property. Cool. But again, I think we can do more, right? Like, this is just a tiny ball, like, jumping around. I think we can do something more interesting. So let's create a cooler AnimationSpec visualizer. And just to, like, not just call it cooler, let's actually call it phase AnimationSpec visualizer and make different phases of this animation animate together. Now, in order to reach this thing, I'm actually not going to be using a lot of animations in order to do it. I'm actually just going to grab my amplitude, and instead of like consume it right away, I'm just going to create a save amplitude lazy float array that is going to preserve my last 5 values. And then I'm just going to be a lazy person, and I'm just going to create a launch effect to touch to my amplitude, and then just populate this float array every time I get more, right? So what this thing is going to do is every time I get an amplitude, depending on how many I have saved, I'm just going to be iterating the value among these 5, which is going to cost me a memory of 5 amplitudes for this. Now, the cool thing is that in order to like make this work, I don't need to change my animations. The only thing I need to do is wrap it in a for each, because I can create as many animations as I want, as they are really efficient. Cool. Now with this, there you have it. More interesting already by just changing some lines. But I am not done, right? Like, we have just done one AnimationSpec configuration. Let's jump into customization number 2, easing. Now, you may have seen easing inside our tween AnimationSpec already, right? Like, it was just added there. But what is actually easing? A way to define easing is that easing is a function that represents the animation fraction. We're again talking about fractions. Another way to like explain this thing is that it's a function that provides the animation value at a given point in its life cycle. You may have started to see a trend here, right? Like, at the end, all animations are basically, I am giving you this time, this is your start, this is your end, give me in which point you are, and give me that value. Now, the important thing about easing is that it is actually not available in all of the animation specs. These are only available in time-based ones, like tween and keyframes. And the main use of them is not to get the actual, like, whole animation spec value. It's mostly used to speed up or speed down the animation. Yes, so, recapping. AnimationSpec is going to be the whole thing. It's basically going to contain the whole information on how this value is going to change. Easing is going to be part of this AnimationSpec, and it's going to be mostly focused on velocity. But to get landed home, let's see an example on how this easing looks like in the out-of-the-box ones. So we have this for animations. All of them are doing objectively the same. They're just basically going from the top to the bottom, and then just like basically gliding in. But, as you can note, depending on the different easing I'm using, I'm getting a different effect. They're all reaching the end of the animation, but they're doing so in a different way. Some of them speed up super quickly, some of them like just go straight, and that's the power of easing. But to make it more clear, if you plot this velocity by time, and yes, I am a math nerd, sorry, you would get these graphs. So it's even more clear how this velocity is changing. As you can see by the plots of these easings, all of them are totally different. And this is basically defining the behavior of the thing you're animating. Now, the cool thing about easing is that since it's basically just a graph, it's super easy to use basically grab that graph and create whatever graph you want and just put it in. Important thing to note here is that, as you can see in the bottom ones of my is out and is in, is that I actually can overshoot the animation by just playing with the value of this, right? But I'm getting a bit ahead of myself. And since we're already talking about custom easings, instead of creating like this boring out-of-the-box easings, let's jump into customization number 3. Custom easings. Now, for custom easings, everything still applies, everything is the same, it's still the velocity. The only difference is that instead of like grabbing the out of the box, we're going to be creating our own easings with our own formulas. And the way you do it is by implementing the interface easing. It is super simple, it just has one function, which is transform, and you have 2 options on how you're going to create your custom easings. If this stopped working, cool. No worries. So option number 1 is to play with cubic bezier easing. Now, this one is out of the box as well, but it's going to be a constructor for easings that is going to let you create some Bezier curves. If you don't know what is that, I invite you to Google it, but basically it's a way to define how a curve is built. Now, playing with these values is already super powerful because you can get different behaviors with that, but actually my most interesting option, or like the one I play the most, is actually just creating a custom easing from scratch, right? As I said, these are basically plots, so you can just grab your favorite formula, like in my case, assign, and then just kind of create an easing using that. And since easings are basically just another class or object, you can create function constructors, you can just create as vals, you can create them as however you want, store them in a list, and just iterate through them. So that's it for custom easings. Pretty straightforward, right? And don't worry, if you're feeling like not super inspired about like, hey, what form I can use or what formula can I grab for this easings, there's a lot of inspiration to get from easings.net that has a lot of formulas already available for you. I see some phones. OK, cool. Now that we have these custom easings in place, let's see how it will look like in our music visualizer. It would look like this. As you can see, by just changing my easing, I can get different behaviors. And even if all of them reaching the top position that I want, they're doing so in a different manner. Cool. But again, this is still boring. Let's create something else. And for the case of easings, I actually went a bit lazy and decided to just create a list of all of them, iterate through them, and create them all together. Nice. And that's for our easing visualizer. The only key thing that you need to remember, again, is that easings are basically just formulas. And these are just basically going to define the speed. So just grab whatever you like, stamp it in, and you're ready. But now that we're talking about custom easings, you may be wondering, hey, what about some custom animation spec, right? We already saw some of that. Well, don't worry, that's going to be our 4th customization option, a custom animation spec. Now, for custom animation spec, don't worry, no one is stopping you to creating your own. You're again going to have 2 options. Option number 1 is to basically use keyframes. As I mentioned before, keyframes are going to let you define specific frames in the animation that you want to reach. So using keyframes, you can get around a lot of the requirements that you have. Option number 2, however, is to basically just create your own custom animation spec from scratch. You usually don't need to do this, as I said. You can get away for most of the time with springs and trains and keyframes, but that's exactly what we're going to do. So let's get into it. In order to do that, again, I'm going to grab my favorite formula, which is assign, and we're going to be creating assign animation spec, which instead of just going linearly to the point, is going to follow a wavy path. So how will we do this? Going back to our AnimationSpec interface, as we know, we need to implement our vectorized animation spec. Now, we basically already saw what we need, which is implementing all these functions. So let's go in order. from bottom up. Oh, sorry, I forgot to mention, my animation spec is a 2D one, so I need to actually use an animated vector 2D for that. And I was super creative and called it my vector spec. Anyway, as I was saying, let's start implementing this thing from the bottom up. And let's start with durations. Now, in order to provide the duration of my animation spec, I can just follow what train is doing, right? I can just create a different parameter that I'm going to pass, and I'm just return that. Done. Cool. Not so bad. Now, let's see velocity. Now, bear with me with velocity. Unless you want to create something really flashy, which is not my case, I just have a boring sine line, you can just get away passing whatever you want here. If you're not going to be using this velocity in the function above, you can just pass a default standard animation 2D with whatever values, and it's going to be ignored. So for an easy animation spec, we can just pass this. That's it. Done. Cool. Going quickly. Now, for the third function that we need to implement, this is where things get a bit mathy. This is where we're going to do the magic of passing the value that I need at a given point for my animation spec, which in my case is sine, right? So the code for this one looks like this. We get the things, we start calculating different points from the beginning, from the end. If you had some geometry to the mathematics at some point, you may see this as before. Once we have that, we start calculating some things with hypotenuse to get distance and everything. But don't worry, even if it looks like a lot, it all boils down to, let's just get the distance from the point you're starting to the point you're going. Give me in which point of time you are. And with these two things, we're just going to calculate a sine. That's it. So even if it looks like too much, you can actually just copy-paste the code I passed before of the distance and you use it for different things. The only thing that you need to change is that key part over there. How are these points going to change? Cool. That's the third function already, so not so bad. Once we have these three functions implemented, the only two things that we need to do is say that my animation spec is not infinite because I want it to finish at the end, and then just return it inside a sine animation spec that is basically just returning this vector. And that's it. We have an animation spec. Not so hard. And since this is basically an animation spec like the other ones we have, in order to use it, the only thing you need to do is going back to your functions, you just basically pass it as another parameter for animation spec. Now, some of you may have noticed that my sine animation spec was 2D actually, and the one we're using for amplitude is just a float. So there's some housekeeping that we need to do, which is basically we need to transform our float to an offset. But once we have that, we have a sine animation spec, which is basically going to wave around and follow the paths. Cool. That is done. Not so hard. And now that we have our custom animation spec and our custom easings, we can start meshing this visualizer together. We can start adding our sine animation. We can start adding our different easings. We can actually add more easings, not just one line. And once we have all of this, we can mimic the same thing we did for different balls to not only change the position, but also change size and color. And once you have this, you can add more things. You can make it fade, you can make it change, you can make it cheap, and that's it. This is our music visualizer. And of course, this is not the end. Once you have these amplitude changes, you can start adding more things. You can start playing with frames, you can start adding waves, you can start changing the different things on how this plays around. But the core thing is the same. If you want to go and play something special, you just need to grab some formulas, make it fun, stamp them in either AnimationSpec or easings, and that's it. Thank you. If you want to learn more, as I said, you can find all this code and much more music visualizers inside my public repository there. You can also check how I'm doing the music readers. There were some issues regarding how to read these files. And I would love to say that I did all of this using use keyframes, but I am actually cheated and I use it animatable. But anyway, after the code, I also recommend the Awesome Acoustics channels. Has a lot of information on how this audio works, and checking, of course, the documentation. And if you want to bother my brother, that I highly recommend, so you can do so in his page over there. But until the next one, that's it. Thank you, and don't forget to vote. If there are any questions, you can find me around a conference, or if not, I'm just going to be around here. Thank you.